something called Digital Coast, which I'll show you. Our tool today is actually part of Digital Coast, and there's a lot of LiDAR data available on Digital Coast, especially right along the coastline. But then in some cases we have to actually go and get the raw LiDAR points and break lines from counties and individual sources to try to build the best data we can. Then when we build an elevation model, there's a lot more we have to do initially to it before we can start mapping. For instance, we have to in some cases define where the shoreline is, because when you try to interpolate a digital elevation model, it'll try to interpolate across the water and end up with ugly looking things like these triangles. So ultimately what we want to do is to end up with a surface that looks like this, where you're taking all that interpolation out, you're telling it not to go across the water, and this is where you want to start out with when you're looking at things like sea level rise. The other issue is what resolution do you want to try to use, and this becomes the math problem because you want to show the highest resolution you can to give the connectivity. For instance, these are some finger canals you see here on the 5-meter resolution. It captures those pretty well, but when you start using up to 10-meter, you start losing some of the connectivity, and this just has to do with the way the rasters work. And but it depends on how big of an area you're mapping. You know, doing it at a finer resolution takes up a lot more computer processing time. So once you have your terrain set and ready to go, and you've done the hydro flattening and conditioning of the DEM to get it ready to do the mapping, you have to figure out what water surface you want to use. And